Hi, I'm Vic Hyde and I'm an environmental scientist. In today's video I'm going to be explaining the work that I'm involved in for Project SAMARCH. That stands for Salmon Conservation Around the Channel. It's an EU project and it includes 5 main rivers throughout England and France. The 2 in England are the River Frome, which I'm on here today, and the River Tamar. In these series of videos I'm going to be explaining the work that the project does, I'm going to be talking to some of the experts, and I'm going to be explaining what we found and how critical it is to our understanding of salmon and trout. For my university placement, I decided to do the Project SAMARCH. So I've been interested in fish and rivers for a long time. This was a good fit for me because I like this area, but I'm sure you'll find a good fit for you too. This was important to me to do because 70% of the Atlantic salmon population has declined since the 1970s. Now salmon and sea trout have an incredible life cycle. They're born in the rivers, they head out to sea when they're older, and they return to the exact same river in which they were born to reproduce and to carry on the cycle. This allows us the opportunity to insert them with a micro tag, similar to those that are used in cats and dogs in their juvenile stage. When they head out to sea and they return, they pass what's called an electronic fish counter, and from this we're able to calculate the proportion of fish that survive, and whether there's less salmon in one year or more salmon in another year. So to do this we need to catch the fish, and we use a process of electro fishing. This involves using a small electric anode in the water and passing a small current through the water. This temporarily stuns the fish and allows us to catch them. But don't worry, they're not harmed at all. So that's what we see in these next few videos. I hope you enjoy, and I hope it gives you an insight into the Project SAMARCH and my university placement. Here we have the fishing team, one person on the
anode and net, spare person to catch any fish with the net that the first person may have missed, one person to carry the bucket with the fish, and the 4th person to carry the boat.
You sort of turn around to the anode and then you've got to track this water.
another safe release. Salmon trotter. The main identifying feature from the salmon is the rounded tail. So I'm going to safely release him now. Give it time to breathe. And I had wet hands before, which helps protect the mucus. So the water and the oxygen is flowing. And we'll just give him a bit of time to rest. There we go, off he swims. So that's the brown trout, Salmon trotter. We reckon that one's a few years old and it's been tagged already, which will be able to tell us more information about the success rate and the lifespan of salmon trout in this river. Okay, so this is the sea trout, the salmon trotter. It's actually the same species as the brown trout, but the difference with this is that it's been to sea for a few years and come back. So the difference you can see, it's a lot more silvery, but the same species. And so that's been out to sea, it come back and spawn and live in the river as well. So that's very nice to see. I'm here today with Stephen from the Game and Wildlife Conservation Trust, asking him about his involvement in the project and the work he does. Hi Stephen, can you tell me more about the job that you do?
Yeah, nice to speak to you, Vic.
Thank you.
I am a fisheries scientist and a statistician.
Okay.
So I get the lucky job of looking at all the numbers, but I also get involved with the collection of the data, and I get to write scientific papers about what the data is telling us. So consider it quite a lucky position. I get to see all aspects of the program, if you like.
Yeah, and I bet it's nice to have the balance between the field work side of things?
Absolutely, yeah, that's a really attractive part of the job for me because I enjoy field work. Who doesn't? I think that's what draws us all to ecology in the first place.
Yeah.
But I think that only makes up about 30% of my time. Probably 70% of my time is spent in front of the computer, wrangling the data and writing reports. But that suits me, as I say, because I quite enjoy doing that.
Okay. And the data support is an important part of the project. So can you tell me about any trends we've noticed in the salmon population here?
Yeah, I would say that without the data analysis, there's really no point in collecting the field data. So I wouldn't say it's an important part, but like the most important part, really. Otherwise, we probably wasting our time collecting data if we're not reporting it somewhere and talking about it, because it does tell us things. And over the 17 years of doing this program, we've seen a decrease in the numbers of salmon coming back to this particular river and other rivers around England and Wales and elsewhere across the British Isles and the salmon's entire range. The juvenile numbers, the data that we're collecting here in September this time of year, those bounce around a little. One year can be good, another year can be bad. I think we're seeing a general trend for fewer but sometimes smaller individuals as well, which is quite interesting.
And what do you think the trend is looking like for this year?
This year, it's a little early days. We were rained off early on, so we can't be entirely sure, but we've certainly seen fewer young of year. That means salmon and trout that were born or hatched from their eggs in spring, this spring in 2020. We're seeing fewer of those than we would expect in many of the areas we've been to, but there are several other areas to go to, and today, for example, the numbers have been pretty good, so fingers crossed for better numbers.
Yeah. And one final question, can you tell me about how we can use the data to fix some of the problems that are affecting the salmon?
So what our data will do is it will certainly give you a site, an area or location specific indication of how the population is varying through time. You can use that data to indicate, it can be an early warning as to a problem with that particular area of the river. So if the numbers are dwindling and continue to dwindle, then it might suggest that there needs to be some work done in that area. We can recommend what that work can be. We're not an organisation that is particularly active in doing that work, but we work with many other people in the catchment here and elsewhere around the country to design the work that can improve conditions. So river restoration, site improvements as well. All of these things can be done, but really you need those numbers to know where they need to be done. And what we do is we'll also then monitor that site afterwards. So if for example we see a dwindling population at a particular location, we might recommend somebody come with us to help us to restore that site. And then we will continue monitoring that site for years afterwards, so we will be able to see the effect of that restoration on the salmon population,
how it's changed over the years,
and how it changes in response to that change as well, which is a good thing. It's a lot of work is done now, but without the pre and post monitoring, so you don't know what the implications of what it is you've done are. Yes, we can learn now from that data.
Okay. Well, thank you for talking to me, Stephen.
You're welcome.
So that was Stephen from the Game and Wildlife Conservation Trust, and he's been explaining how important his role as data officer is with the project. Thank you.